All right, now that we have the July the 4th weekend upon us, I got a little bit extra time to finish up these projects. You may remember this one. I think I just did a video clip for this, so I'll edit it together. So this might sound redundant if it's all in the same video, but just to recap, this board here, I did a few years ago a video on and showed that the capacitors were leaking and the resistors were damaged. These resistors supply current to the drive transformer. All that's been removed. Well, I went on eBay and I found what I thought was a new old stock board because it was still in the service box. Turns out someone had pulled the good part out and put the junk one in. This one has a bad flyback, but the board is in better condition. Okay, so I think what I want to do, instead of recapping this board, I'm going to dedicate this board for parts because it blew the horizontal output transistor anyways, while this one's still good. So I think I'm just going to move the flyback off of this one onto this board and just recap this board. Because what was wrong with this board is it's got a bad flyback, and that's why it was retired all those years ago. And since this was retired, you know, during the service period where Apple was still serving this stuff, chances are this board doesn't have as many hours on it it could potentially have. But so here's the flyback that was originally in there. I had removed it, and you can see what happened to it. There's burn through on this module, and you can kind of see the crack. So I think moisture infusion caused that to happen. But that is the network for both the Focus and G2, and this is the big dropping resistor that's in here. But anyway, so I might hang on to this flyback and potentially cut this open with a Dremel and see if I can't fix this, because it throws an arc right here. The flyback, it still works. It still produces high voltage, so the windings and stuff in this transformer are still good. It might be worth hanging on to and see if we can't do a video or something repairing this, potentially, because you're not going to find these transformers anymore. I mean, you might be able to find one or two that are new old stock every once in a while, but you're not going to get these. And the more of these that die, the less of these monitors will be out in the wild working. It's just, it just is. Unless you can find a generic replacement, and sometimes you can, sometimes you can't. But these aren't made anymore. So anything that you're going to find today are going to be, you know, new old stock or potentially used or whatever. So it's worth hanging on to as a project to see if we can't fix this. But regardless, this is a spare board anyways. I'm just going to hang on to this board here as a parts board in case, you know, I got a vertical output IC or something that fails. I can just go on this board and move it over. You know what I mean? So it's always good to have parts boards. The collection is going to hardly ever be used anyways, but even if it does, and if there's a failure, I have parts to move across. So anyways, this is a sad situation, but it is what it is. We're going to go ahead and finish recapping that. I got all my capacitors over here and all that fun stuff. Also, I have that now. That'll be a project for a future video, I hope. Meanwhile, let's go ahead and start recapping and get this thing done. Okay, so I figured I'm in the middle of recapping this thing, and I figured I would go ahead and point out something because this is important to pay attention to. When I did a quick and dirty cap list of this thing, there's a capacitor here that's a 47 microfarad at 25 volt, and I went ahead and, you know, picked one out. No problem, right? Well, I just realized there's no positive and negative indicator than, say, compared to these. And then when I pulled it out, I realized that this is a bipolar capacitor, 22 microfarad at 25 volts. So, and the problem with this capacitor is, if I can get it back out of here, and if this will focus on it, but right up in the pins, it's hard to see, but there's a little bit of signs of the green crustiness. It's like right up inside the pin. So this capacitor is definitely bad. Unfortunately, the ones that I ordered, 27 or 22 microfarad at 25 volt, are polarized. So that's not going to work. Gist to the story here is make sure that you pay attention which ones are polarized and which ones are not. Because you don't want to make the same mistake I did. Plus, I forgot this one too. I thought this one was a 100 at 10 volt. It's actually a 10 at 100 volt. So I installed it over here. But this is the same thing over there, and I'm missing it. So I have to get the correct one for over there. Anyways, just a side note, make sure to double, triple, quadruple check when you're doing a cap list for something like this. Another thing I want to note, as the capacitor replacement is coming to a close here, the first thing, well, while you have this thing apart, the next thing you want to check after you get all the caps installed is obviously double check all your work, make sure your polarities are correct in the right order and stuff like that. But more importantly, while you're in here, you might as well hit up all the common trouble spots that bad connections like to develop, such as, you know, these transistors here, all these connectors, ICs. I got some more soldering I got to do over here. It's same thing with the flyback transformer, resolder all of that. Any of these transistors that get hot tend to break their joints, so do all of that. Same thing with the CRT neck board. I've got the capacitors replaced on there, but again, you want to go through and check and resolder all of these header pins because they tend to crack in the corners especially. Same thing with the CRT socket from the heating and cooling cycles. Any of these other little components, like they're starting to get a bit dodgy in here. So just while you have it apart, go through the common resoldering trouble spots, because if you don't do that, you're asking for problems later. So make sure while you have it apart, while you've already got it on the bench, just to go ahead and do that. So the next thing I want to point out is when you're in a situation like I am, when you don't need to order anything else, because I'm not going to make another Mauser order for a while. So the last thing I want to do is just order up a capacitor and pay all that shipping just for one cap that I'm going to be using on this. Sure, I could order a few of them, but I don't want to sit on it either, because just like with this stuff, you know, if you order excessive electrolytics and you're going to sit on them for years and years at a time, they're going to go bad. They're going to dry out. They're going to go bad, just like they go bad when they're sitting in here. So you really got to budget what you're going to spend and all that stuff. That's a conversation topic for another time. But anyways, and when you're in a situation like me where you have a bipolar capacitor and you don't have the right value on hand, like this is a 22 microfarad at 25 volts, there's one thing you can do. Some of you may already know this, some of you don't, and the people that don't, this is why I'm going to go ahead and show you this. When you take two capacitors, or multiple, they work opposite of resistors. So if you put capacitors in series, the capacitance will be divided while the voltage is compounded. It's doubled, okay? But if you put capacitors in parallel, the voltage stays the same, but the capacitance will double, okay? Unlike resistors work the opposite. When you put resistors in series, the resistances add together, while if you put resistors in parallel, they divide against each other. Caps work the opposite. When you put them in series, they divide against each other. So what we now know is we have a 22 microfarad capacitor. So what you can do with this is you can take two polar capacitors, such as these right here, okay? But you can take the same side on both caps, like this white stripe, that's the negative. I can take the negative of this capacitor here and I can actually put them together. Now what you effectively have, these are 47 microfarad capacitors. So what you're going to do is you're going to get, if you connect it like this, you connect the same sides together, whether it's dual positive or dual negative. I'm going to do dual negative. And really the difference between the two is based on the noise immunity in a circuit, because the negative is part of the shell, I believe. I could be wrong. Anyways, moral of the story is when you connect the same sides together, now you have dual positive leads or dual negative leads. Congratulations, you now have a bipolar capacitor with the capacitance divided in half. So you're going to get somewhere around 20 something microfarads. So it's going to take the 240s and divide them in half, and you're going to get roughly 22. In this circuit, it's part of the vertical centering control, so it's not super critical. I can always tweak that a little bit. So this will solve my problem, and this will get you out of a pickle in case you do not have one of these on hand. So you can just take the two of the same polarities, tie it together. Now you have a bipolar capacitor. that is divided in half of the microfarad value and doubled in voltage. So this is now a 20 something microfarad capacitor at 50 volts. So just keep that in mind. You can do that. All right, the next thing I want to address is right here. I think I've mentioned this earlier in the video, but I have two of these resistors here, and these get extremely hot and is notorious for cooking these capacitors, and they leak pretty bad. But the fact that these are scorched, they tend to want to drift in value, and these supply the current flow to drive the horizontal output transistor. So if we look at the circuit itself, we can see that we're coming off the drive transformer, going through resistor 1 and 2, and then all the way down around to the base of the horizontal output transistor. It goes base, collector, emitter. Damper diode is built into the transistor. So anyways, these are notorious for failure. They get really hot and they cause problems. And then they'll get so hot, sometimes they'll bleach the values of the resistors. And I remember it coming up in a conversation, someone had asked me what those values were, and I don't remember. So I want to address this in this video. So if you get these resistors, we're going to replace them anyway because I ordered new ones. But if you need those resistors, they should be 8.2 or 0.82. Hold on, I'll have to pull them out. But yeah, you have to change those. What I did here is these are 0.82 ohms, which should be the same value we have over here. Looks to be. So we got 0.82 ohms at 2 watts. So what we're going to do is we're just going to go ahead and replace these two with these, and that way we'll give it some longevity because these values drift. They're metal film resistors too, so we're going to go ahead and take care of that. Alright, I got the new resistors in place here, and since these things run very hot, what I did was I soldered it in 2 places, here and up here across the leads, just to make sure this thing's not going to want to come apart. But that should be it. The next thing I got to do is I need to move the flyback over from the junk board, which is down here. Once I get the flyback moved over, this thing's ready to be put back inside the machine and powered up. I got to put the shields back on. But getting those shields off was a nightmare. And why does that come over there? It doesn't belong there. Yeah, getting those shields off was a nightmare because there's solder points all the way around the board. Thank God for this thing. I mean, wow. Turn that off. I don't need it on anymore. So we should be good. I'm going to move over, and then we're going to pick this up right when I got this thing all inside the monitor and we're ready to power it up. Got the flyback extracted. This one's, doesn't have that burn hole in it. Time to put it together and hope like hell, say a prayer that this shit works. Alright. The new flyback in it is in, well, somewhat new. There's the old one here that I'm going to try to fix eventually, but new flyback is in, all new capacitors are in. Now it's time to go grab the chassis. Well, let me rephrase that. The CRT and bezel assembly and put this, which is the chassis, back in. So another thing you got to make a note of too when you're working on this, like for example the CRT neck board here, the focus lead for the CRT is soldered on, which goes up under this cover. You got to make sure when you solder the wire on and off that you clean up any boogers or any strands of wire laying down there the best you can, because there's a few kilovolts going into this, and any boogers close to ground or whatever, you're going to get arcing. So you got to make sure that it's all clean and ready to go. So I'm going to solder that guy back in there, and then we're going to put this thing back together. It's been a long time since I had this one out. The last video I did on this thing was 2017. Prior to that, when it was working, was 2014. So it's been a while. 7 years. Anyway, so now I got it off apart again, so it's time to get the chassis in there. But the one thing I wanted to make sure of first before I did anything is I need to check all these wires. But I also need to get in here and clean up that capacitor mess before I slide the board in here. So let's get that done. And this is why I hate mice. Apparently a mouse got in here within the past 3-4 years and decided it wanted to chew my wires off to the front panel LED. Well, ain't that nice? Now I gotta fix that. Well, that's fixed as about as best as it can be. I mean, relatively speaking. He decided to eat it all the way up in there, and I'm not pulling that CRT out unless I have to. I was inspecting other wires. I didn't see any other damage, because if he would have eaten my yoke or something, I would have been pissed. So, yeah. And the thing is I've got mouse traps and stuff in here too, because mice really want to... I live out in the woods, so mice really want to get in here and eat shit. So, anyways, moving along. So here's the problem with working on stuff, 5 to 7 years ago and forgetting about it. I got a big pile of parts there, a couple of cables here, and lots of wires here. So I got to figure out, I think this one goes back here. No, maybe this one I don't know. Yeah, LED plugged in over there. That's the one I got eaten apart. Yeah, I got a thing here. Yep. Note to self. Don't tear shit apart and leave it sit for 5 to 7 years, because you're going to forget how it goes back together. Well, that was fun. I had to let my instincts take over to figure out where everything goes. It's probably not exactly where it was before, but it's pretty close. That's kind of loose because there's some plastic pieces that got broke that hold the CRT in. So it's kind of like, okay, I'm going to have to get some silicone down there or something and hold that out. And the plastic piece went right here, so it wasn't too bad once I started jogging my memory a little bit. The last thing I need to do is I need to move the button over without knocking all this crap over. Yeah, 1 second. I need the camera out of my hand. Alright. Perfect. Well, I guess at this point, it's now or never. I don't have a Mac to plug into this thing right now, but I can plug the power in and see if it explodes. Okay. Alright. It's either going to work or it's not. Hey, I got high voltage. Everything came on. Watch for any smells. Got a green light. Well, nothing out of the ordinary. Squeaky. Alright, well. I got high voltage. Everything came on, so I guess I gotta go grab a computer and we'll see how it works after that. I've only got this. The only screws I have left is these two, which goes in the case. That and this screw goes together, and that went to the horizontal or the vertical output, which is down here on the old board. So I already know where everything goes. All right, well, let's move on, shall we? All right, got the LC3 out. Hopefully this will be the final installment. So let's turn the power on again, and let's all right. Hopefully we get something here. Holy crap. It's going to need some adjustment, but yeah, I got to clean that pot. We got some burn-in, which I'm not surprised. But it works. Definitely after the recap, I've lost some geometry and I've got some Crap, it's switching into 32-bit mode. That's why it does that. Yeah, I gotta do some work with the pots, but make sure it's not. I got a bad cable. Dang it. I'm gonna have to make a new cable for this guy. Yep, I gotta make a new cable. Oh well, it is what it is. But hey, it works. It's good enough. That's why I took this cable apart. It makes sense now. I couldn't remember why I took this cable apart. Now I know why. It's got a bad, right here. It's defective, see? I can just wiggle on it and it just goes in and out. But we'll work on that. The important thing is, the point of this video was for a recap and replacement of the flyback from a different board. But it was basically a recap that caused this thing to fail originally with the bad caps. So it's all good now, and you can see where that guy was leaking. There's all the original ones. Anyway, we're good. Thank you for watching, and if you have a comment, please feel free to leave one.